हेलो फ्रेंड्स, कैसे हो आप लोग? माई सेल्फ चेतन गर्ग. आई एम मास्टर टीचर here at Vedantu. I welcome you all to our RMO Flashback series, right? So in this series, we will be discussing, in today's lecture, we will be discussing question number 3 and question number 4 of year 1991, right? Again, I encourage you to, if you haven't solved these questions, kindly pause the video after watching the question and just give a sincere effort to solve the question. And still, if you are unable to solve it, you can come back and you can see the solution, right? So let's start with our first question, question number 3. And before starting, let me give you just a little information about the batches that we are currently running here at Vedantu, right? Currently, we are running pre-RMO, RMO, and INMO batches here at Vedantu. And those who have not cleared pre-RMO or have not appeared yet for pre-RMO, they can simply visit our website olympiad.vedantu.com. Here, they will get all the information regarding the pre-RMO batches. And those who have already cleared pre-RMO and or RMO exam, they can simply just mail me their name, class, their proof of clearing these exams, their contact number and address to this email ID, right? Those who have cleared pre-RMO, we will simply enroll you to RMO batches, and those who have cleared RMO exams, simply enroll you to INMO batches, right? So all you need to do is just mail me this information. We'll enroll you to the respective batches, right? So without wasting much of your time, let's start the session. Okay. So this is the question number 3 of RMO 1991, right? This is the question of number theory. Let's discuss what the question is saying. The question says that a 4-digit number has the following properties, right? It is a perfect square, perfect. Its first 2 digits are equal to each other, great. And its last 2 digits are also equal to each other, right? Now we need to find all such 4-digit numbers, right? Okay, so according to the question, the number is like AABB, right? All first 2 digits are equals, second last 2 digits are equal, right? And this number is also a perfect square, right? So okay, let's see. If you clearly see that this number will be a multiple of 11, right? We can write this number as 11 into A0B, right? Where A and B are single digits and 0, as you can say, right? So if you multiply this by 11, you will get AABB. Now since this is a perfect square, right, as it is mentioned in the question, this is a perfect square, right? And clearly 11 is a multiple of this. That means 11 must be a multiple of A0B, right? So this A0B, where A and B are single digits, right? This should be, this A0B, this should be 11 times something. And since again this number is a perfect square, so it should be a perfect square, right? तो अभी हमारा क्वेश्चन किस चीज पे रह गया? वी नीड टू फाइंड some k square such that 11 into k square will give us a 3-digit number whose middle digit is nothing but 0, right? So all right, let's see. If k square is a single digit, right? Let's assume if k square is a single digit, right? K square is a single digit, let's assume. Now what will be 11 into maximum, that will be a k square, then have a maximum value of 9. Then in that case 11 into 9 will be 99, and it is a 2-digit number, right? So A0B is not possible for a single digit perfect square, right? Now if we see k square to be greater than or equal to 100, so it will simply give us A0B to be equals to 1100, in fact greater than or equal to 1100. Again that is not possible because A0B is a 3-digit number, right? So that cannot be greater than or equal to 1100. So we have strike out the possibility that k is 3. We have strike out the possibility that k is 10. So all we are left with is that k can be any one of the following, that is 4, 5, 6, 7, 8, 9, right? And in fact k square will be a 2-digit number, right? Now if you see, let's assume k square to be xy. Let's assume k square is a 2-digit number, that is xy. Now if you multiply 11 with this xy, what you will get? You will get xy, let's say xy into 11. What we will get? We will get xy Okay, okay, I just write it here, right? So xy when multiplied by 11, we will get xy, here it is. So we will get y and this x plus y, right? And if there is a carry, then this will be x plus 1 or it will be x. The point is this x plus y should give us 0, right? So what I'm trying to say, these two numbers, okay, some of these two digits should be 10, or some of these two digits should end up with at least 0, or you can say 4 square is nothing but 16, right? So k square will belongs to 4 square is nothing but 16, 5 square is 25, 36, 7 square is 49, 8 square is 64, 9 square is 81, right? So k square will simply belongs to these values. Some of these digits is not end up with 0, neither is this, neither 639 and 9413, but 64. This 64 ends up with 10, right? So k square must be 64. That is 11 when multiplied by 64. What we will get? We will get 64, right? So this is nothing but 704, right? Again, this ends up with clearly 0, right? Standard digit of this number is 0, right? So what is our AABB? It is nothing but 11 multiplied by this 704. So when this 704 multiplied by 11, what we will get? We will get simply, as you can see, 7744, right? So this is the only number, right, which is a perfect square, right, which ends with identical two digits and which also starts with, that is basically the first two digits are also identical. And this 7744, whose perfect square it is nothing but 11 into 8 square, right? That is 88 square. If you compute the whole square of 88, it will end up with 7744, right? So this is the answer for this question, right? So this is a question of basically number theory, and it's pretty simple question. In fact, I think a student who is currently in 8th or 9th standard can easily attempt this question, right? All he need to do is just manipulate the numbers and consider these cases when k will be equals to this, right? Chalo, now let's proceed to question number 4th, right? Okay, this seems to be a big question. Let's study the question first. There are two boxes, there are two urns, each containing an arbitrary number of balls, okay? Both are non-empty to begin with, right? We are allowed two types of operations: remove an equal number of balls simultaneously from the urns, okay, or we can double the number of balls in any one of them, right? What we need to prove? We need to prove something. We need to prove that after performing these operations finitely many times, both the urns can be made empty. Okay, right, perfect. So this is a good question, and in fact this question doesn't require any mathematical knowledge, right? This is just a question of you can say picking and dropping balls, right? So let's try to figure out what this question is saying by taking some examples, right? So let's say our there are two boxes A and B, right? Our first box contains some random balls, let's say 4 number of balls, right? And B box contain, let's say 13 number of balls, right? So we can do only two type of operations. Okay, two type of operations are allowed. First operation is we can remove equal number of balls simultaneously from the urns. Okay. Second operation is we can double the number of balls in any one of them, right? So finally our aim is that after performing some finite steps, right, we need to empty both the urns. तो बेसिकली इस टाइप के जब भी क्वेश्चन होते हैं, एक बार है ना क्वेश्चन की फील लेने के लिए या क्वेश्चन की अप्रोच बनाने के लिए ऑलवेज ट्राई टू फिगर आउट, ऑलवेज ट्राई टू वर्क आउट विद सम एग्जांपल्स, राइट? जैसे अभी हमने एक रैंडम एग्जांपल लिए है ना, व्हेन नंबर ऑफ बॉल्स इन फर्स्ट बॉक्स इज 4 एंड दैट इन द सेकंड बॉक्स इज 13, राइट? Let's see whether we can empty them or not. I'll simply multiply, I'll simply double this balls, so it will be now 8, 13, right? What should I do now? If you see the gap here is 5, right? If I double this 8, it will become 16, so that will be of no use, है ना? Simply A will be greater than B and we can repeat this process and so on, right? So the gap here is 5. If I take three balls from both the boxes, right? So what I will end up with 5 and 8 here, right? Oh, sorry, 10 here. if I remove 3 balls from both the boxes, I'll end up with 5 and 10 balls, right? Now if I double this, double the balls in A box, I'll end up with 10 and 10. Now since I can remove equal number of balls, I remove 10 balls, but I'll get 0 0. So in this way, I have emptied both the boxes, right? Let's take another example. AB. Let's assume this time A has 1 and B has anything, let's say 11, right? What we will do, first we will double it to 11, right? Because if we have removed one ball, then here it will become 0. If one box is 0, one box have 0 balls, and the other has some balls, then we cannot empty both of them after performing any finite number of operations, right? Because we need to remove equal number of balls simultaneously. So again, let's double it. So we'll get 411. Again, let's double it. We'll get 811. Now if we double it, we'll get 1611, and that will not make much sense. Now here the gap is 3. So if I remove or if I make this to stand at the gap, that is 3, how many balls I need to withdraw? 5 balls, right? So removing 5 balls from both the boxes, what we will end up with? We will end up with 3 here, and we will end up with 6 here, right? So the point is, now this has exactly half the number of balls which is there in the second box, right? Now let's double the number of balls in box A, and here it is 6. Now you can remove all the 6 balls as they are equal, so we'll end up with again 0 0, right? So I've given a clear hint how to proceed with this question, right? Let's take some more numbers, A and B. Now let's assume one has 13 balls and one has, let's say, how many? 15 balls, or let's say 17 balls, right? So what is the gap? The gap here is 4. Now either we can double it or we can remove equal number of balls. If we remove equal number of balls, the gap will remain same. Like if you remove 1 1, what is the gap? 12 16, right? The gap is again 4. If you remove 1 more ball, what will be the gap? The gap is unchanged, right? So likewise doing it, if I somehow make this number, the smaller number, equals to the gap that we currently have. Now since the gap is same, so this box will have twice the gap, right? This box will simply have the number of balls which is twice the gap, right? What I'm trying to say is that here the gap is 4, right? I will remove that many balls which will make this box A such that the box A will have only 4 balls, right? So how many balls I need to remove? I need to remove 7 balls from both the boxes. Okay, let's remove 7 from both the boxes. What we will have? We will have 4 here, and what we will have? We will have simply 8 here. Now since clearly this has twice that in box A, right? So we will just double the number of balls in box A. We will get 8 8. Now you can remove both all the 8 balls here, right? So that this will end up with 0 and 0. तो आई होप अभी आपको अप्रोच समझ में आ गई होगी, ठीक है? तो एक और एग्जांपल से हम इसको और थोड़ा सा क्लियर करना चाहेंगे. लेट्स से दिस टाइम वी हैव सम, लेट्स से 20 balls here, 23 balls here. So what you need to do, you need to just look up the gap, look up at the gap. The gap is 3 balls, right? Now I want this number to be reduced to 3. So how many balls I need to remove? I need to remove 17 balls from both the boxes, right? After that, this number will, the box A will contain 3 and box B will simply contain 6, right? So I hope मैंने अभी आपको एक strategy दे दी है how you should work with this, ठीक है? But there is a catch. Let's say if box A has, let's say, 5 balls and let's say box B has let's say 13 balls, right? Now what is the gap? The gap is 7. Now you cannot make this box A to come up to 7 balls, right? Because 7 is clearly greater than 5. So you cannot remove some balls such that this A will come to 7, right? This is practically not possible. So what you should do, you should first try to make this number which is closer to 13, right? We can simply double this 5, we can double it, and we can take it to 10 and 13. If we again double the number of balls of A, this will exceed the number of balls of B, right? So that will not serve any purpose, because simply we can interchange A and B then, right? So now since the gap is 3, and we can make this number to fall to 3 by removing how many balls? By removing 7 balls from each box. Now just let's remove 7 balls from each box. यहाँ पर 3 रह जाएंगे, and how many balls will be there in the box B? Here it will be 6 balls, right? Now you can simply double this number, and the number of balls are same. You can remove the equal number of balls, that is we are left with now both the empty boxes, right? So this is one approach, although we will write it mathematically in some time, right? Now let's discuss one more approach. Okay, this is quite good approach that I like the most. Let's say A and B has some balls, right? So let's say A has 4 balls and B has, let's say, 20 balls, just for an example, right? Now I have made this A to contain just 1 balls, ठीक है? तो मैंने क्या किया, मैंने A में से कुछ बॉल्स निकाल दी जो बेसिकली स्मॉलर बॉक्स था, है ना, जिसमें स्मॉलर नंबर ऑफ बॉल्स हैं, उसमें इतनी बॉल्स निकाल दी सच दैट फाइनली उसमें एक ही नंबर ऑफ बॉल बचे, राइट? सो आई हैव बेसिकली रिमूव्ड 3 बॉल्स फ्रॉम ईच बॉक्स. तो हियर आई विल बी लेफ्ट विद 1 बॉल, हियर आई विल बी लेफ्ट विद 17 बॉल्स, राइट? नाउ व्हाट आई हैव डन, मैंने ए बॉक्स के जिसमें बेसिकली अभी 1 बॉल है उसको डबल कर दिया, राइट? तो नाउ द नंबर इज 217. And again I have removed one each from both the boxes, but I left with 116. As you can say, here the number was 117. Now we have come to 116. What I'll be doing now, I'll simply double this number. Now this will become 2, and this number will remain same, 16. And again I have removed 1 each. So this is 115. And I'll continue this process so on. Basically this is doing what? Box A will finally have 1 ball, and number of balls in box B is reducing by 1 unit. Before it was 17, right? After that it becomes 16. After that it becomes 15. Now I'll double this number, and this remains same. I again remove each 1 ball from both the boxes. Now the number of balls remaining is 114. As you can see, the number of balls in box B is reducing by 1 unit. So I'll repeat this process until when I got the number of balls in box B to be 2, and definitely I'll definitely achieve at this stage, because I'm reducing the number by 1 only, right? So what I'll do now, I'll simply double it, and both these numbers are same. I will remove them such that both will contain 0, right? So this is another approach which is entirely different approach, in which you can make after some finite operations, you can make both the urns empty, right? Okay, so let's write a formal solution for let's say we'll write the formal solution for first part, I mean first method that I have told you. I'll leave the formal solution for second for your own, right? Chalo, let's write the first method. Let's say box A has initially A number of balls, and box B has B number of balls, right? So simply there will be 2 cases. Let's say if A is equals to B, I guess then we are done. We'll simply remove all these balls from both the boxes, because the number of balls are same, right? So let's consider case 2. In this case we can assume without loss of generality that number of balls in box A is less than B, right? If it is greater than B, we'll simply interchange both the boxes, right? तो हमने मान लिया कि let's assume, in fact without loss of generality we can assume that A is less than B, ठीक है? तो what we will do, we will double the number of balls in A to a point C such that C is less than B, but B is less than 2C, right? For example, let's say box A has 3 balls and box B has, let's say, 25 balls, right? So we will double it A, and we will have 6. Why we are doubling it? Because this 2A, that is 6, is still less than B, right? So 6 is less than 25. All right. We'll again double 6. We will get how much? 12. 12 is less than 25, but 2c, which is 24. 24 is still less than 25. We need 2c to be greater than b, right? So we will again double it. Actually, we want to double it till we reach closer to b. Now, अगर अब हम double करेंगे, we will exceed b, right? So we'll stop here. Now our c is that such that number of balls in A is less than that in B, but twice the number of balls in A that will be greater than that in B, right? ठीक है, तो अभी हम क्या करेंगे? What we want here, the gap is B minus C, right? Or we want this first box to have number of balls that is equal to B minus C. So how many balls we need to subtract? We need to subtract C minus B minus C balls from each of the box, and this is nothing but this is 2C minus B, right? So simply and you can see this is positive because of this reason, right? So what we will do, we will simply subtract 2C minus B balls from each of the box, right? So what we will get, we will get here simply B minus C, and here what we will get twice of B minus C, as जैसा हमने आपको काफ़ी पहले examples में बताया था, है ना? This is what we have reached. Now we will simply double this, twice of B minus C, twice of B minus C, and we will since these two numbers are equal, we will simply remove all the balls from both the boxes, and we will end up with both empty box, right? So this is the algorithm that you should follow for any number of general balls A and B, right? So that's this was a good question. In fact, I will say this question number 3 and question number 4 are both doable for a kid who is currently in 8th or 9th standard, right? This entirely needs some logic, that's it, right? So by this I'll end my session, and before ending I'll again tell you that we are currently here at Vedantu, we are running pre-RMO, RMO and INMO batches. Those who have already cleared pre-RMO or RMO, they can just simply mail me their name, their class, their proof that they have cleared any one of the exam, their contact number and address to this email ID. We will simply enroll you, those who have cleared pre-RMO, we will simply enroll you to RMO batches, and those who have cleared RMO, we will simply enroll you to INMO batches, right? So that's it from my side, guys. In the next lecture, we will be discussing next two questions of year 1991. Thank you. Bye bye.